The another topic is the diagonal scale. Before starting the diagonal scale, this is the first problem that I have discussed when we are doing the plane scale. Okay, so I want to tell you is the as I want to draw the plane scale. Your plane scale should be drawn with the help of a HB pencil. Okay, I am dividing the plane scale into the 6 equal parts. Okay, so this is your construction work that I am doing to or divide the scale into the six equal parts. The similar way, this is your construction work. So the construction work you should draw with the help of a twist pencil. Okay, and this is your extension line. It is your dimension line. Extension line and dimension line you should draw with the help of a twist pencil. And the dimensions you have written here, it should be written with the help of a HB pencil. Similarly, the units you should write with the help of a HB pencils. And also the one thing that the units that you are writing, you should write just below the scale and just right side to the last term your numbers. Similarly, here you should write the decimeters just below the scale and left side to this number. It should not overwrite. Okay. The similar way, the RF should write with the help of a HB pencil. Okay. The another topic is the diagonal scale. So as I told you, the minimum or least count of the diagonal scale is the 0.01. Okay. So what is the principle of construction of a diagonal scale? So for understand the principle of to understand the principle of the diagonal scale, let draw the line of let draw the line xy as shown in the figure. Then draw a perpendicular line from y. Okay, and up to the point z. Then join the point x with z and divide the yz into the 10 equal parts. Okay, so suppose so xy line is nothing but the subunit. Okay, so I am, for example, I am taking the meter, decimeter and centimeter. So your main unit is the meter. Okay, and the sub unit is the decimeter, and this subdivision of the sub unit, that is the centimeter. So xy is nothing but the 1 decimeter, and I want to divide it 1 decimeter into the another 10 equal parts, which will show the 1 centimeter. Okay, so for that I will divide the yz into the 10 equal parts. So, and I will name the each point like it is 10 days, it is 9 and 9 days. Like that I can name all the points. Okay, so from the geometry we know that similar triangles have their like sides proportional. Like, so I am considering two similar triangles xyz and 7-7z. So this is xyz and 7-7z. From that I will get 7z divided by yz. This is your 7z divided by yz equal to 7 dash divided by xy. Okay, so what I want to calculate is the 7 dash. Okay, so 7 dash equal to 7z divided by yz into xy, and 7z divided by yz is nothing but 7 by 10. Okay, because I have divided the yz into the 10 equal parts, so the ratio of 7z divided by yz is nothing but the 7 by 10. So 7 dash is nothing but the 0.7 xy, right? Similarly, you can say the 1 dash is nothing but the 0.1 xy. 2 dash is nothing but the 0.2 of xy. Thus, it is very clear that the sides of a small triangles which are parallel to divide lines become progressively shorter in a length by 0.1 xy. We are using this principle to construct our diagonal scale. It will be clear how we are constructing the diagonal scale by means of example in the next slide. So here it is the first problem. The distance between Delhi and Agra is 200 kilometers. In a railway map, it is represented by a line of 5 centimeter long. From here, you can calculate the RF. Find its RF. Draw a diagonal scale to show a single kilometer. So least count is a kilometer, and the maximum length that we have to show is the maximum length is 600 kilometers. Then indicate on it the following distances. First one is 222 kilometers. Second one is 336 kilometers. Third one is 459, 569 kilometers. For constructing a diagonal scale, first we have to find the RF. So the RF is nothing but the 5 centimeter divided by 200 kilometer. It is coming out to be 1 by 40 lakhs. Then the length of the scale will be the maximum length, that is 600 kilometers. We can multiply the maximum length with the RF. So it is coming out to be 15 centimeters. So first draw a line of a 15 centimeter long. Okay, then it will represent the 600 kilometers. Divide it into the 6 equal parts. So each part will represent the 100 kilometers. So it is the same as we have done in the plane scale. Then divide the first part into the 10 equal parts. It is also same as the we have done in the plane scale. So the each part will represent the 10 kilometers. Then draw a line upward from the left hand. So we have to draw a line from here, from the left hand, and divide it into the 10 equal parts. Okay, so like in a plane scale you are dividing, the same way you have to divide these two parts. Now we have to divide these subdivisions into the 10 equal parts. Means it is showing the 10 kilometers, each part is showing the 10 kilometers. Then we have divided this subdivision into the 10 equal parts, so that the least count will be the 1 kilometer. For that, I will divide this line into the 10 equal parts, the same way as we have done in the plane scale. Okay, so I will draw a line here and I will cut it into the 10 equal parts. So now, right now I am cutting it into the 5 equal parts. Okay, so so from the last point I will join the last point of the line, and then I will draw the parallel line. So this way you can divide it into the 5 equal parts. The similar way you can divide this line into the 10 equal parts, like that. Okay, after dividing it into the 10 equal parts, okay, I will mark the points from bottom to the top, 0 to 10. So then I will join the ninth subdivision of the horizontal scale, that is this one, with 10th division of the vertical division, means this one. Okay, so you can see here this part is look like a diagonal scale. In the previous slide I have shown you, so this portion is nothing but the diagonal line. Because of that it is called as a diagonal scale. After that I will draw the parallel lines to this line from remaining subdivisions. So I will draw the parallel lines like this. Okay, so now our diagonal scale is completed. Okay, and this scale has a unit of kilometers. This scale has also This scale also has a unit of a kilometer, and this scale also has a unit of a kilometers. After that, in the question, it has asked that to show a distance of 2 to 2 kilometers, 222 kilometers. So first of all, it is showing the distance of 569 kilometers. Okay, so 500 kilometers you can measure it from here. Then it is a 60 kilometers. So 60 kilometers you can measure from here, 1, 2, 3, 4, 5 and 6. Then it is a 9 kilometers. For 9 kilometers you have to go up through this line, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is your 9, or you can also read it from the here, it is your 9, and this is your line which is showing this 60 kilometers. So this point is now showing the 69 kilometers. So from here up to 500 kilometers, it is showing the length of a 569 kilometers. The similar way you can also find the other distances. Okay, so now it is measuring the 459 kilometers. Then again it is 336 kilometers. Doing that, see, this is your diagonal scale. That is the main work that is we want to draw. So diagonal scale you have to draw with the help of a HB pencil. These things like numbers are written here. Also you have to write with the help of a HB pencil. You have to write the RF with the help of a HB pencil. This is your dimension lines. This is your extension lines. These lines you have to draw with the help of a 2H pencil, and the dimensions that is written over here you have to write it with the help of a HB pencil. Okay, and when you are cutting this diagonal scale into the 6 equal parts or 10 equal parts, those are the construction works. So those you have to do with the help of a 2H pencil. Okay, after doing that, see, this is your another 10 parts that you are doing for making the diagonal scale. So when you are drawing the horizontal lines inside the diagonal scale, you should draw with the help of a 2H pencil. Why? If you draw it with the help of a HB pencil, then your drawing will not be clear. Okay, although it is a part of a diagonal scale, but you should draw it with the help of a 2H pencils. Also, these diagonal lines you should draw with the help of a 2H pencil. Okay, or also see, these portions, like you are drawing the horizontal line up to here, that is not worth. Why? Because important it is important up to this part only, right? So you can draw the horizontal line up to the this part, so your drawing will be clear. Okay, so these are the little and minor things that you can use to for the better look of your drawing, and also it will save your time. Okay, whenever I am writing the units, okay, so your unit should be somewhere here near to the scale. Okay, so it is your scale is ended up here, so just after that you should write the units, not here, not here. Okay, just below the drawing, and also you can see it is just below the drawing on the left side, and here you can write it like this. So now the another question is, a rectangular plot of a land measuring 1.28 hectare is represented on a map by a similar rectangle of 8 square kilometers. So from this information you can find out the RF. Calculate the RF of the scale. Draw a diagonal scale to read single meters and show a distance of a 438 meters on it. So the least count of a diagonal scale should be a single meter, 1 meter. So first of all, we will find the RF. So 1 hectare is nothing but the 10,000 square meters. So 1 square centimeter will represent the this amount divided by 8. Okay, then it is a square centimeter. So I want to convert it into the linear scale. So 1 centimeter on the map represents the under root of that amount. This is coming out to be a 4,000 centimeters. So the RF of the scale will be 1 by 4,000. As we have to show the distance of a 438 meters, and the maximum length that we have to represent is not given. So we can choose the distance that should be greater than 438 meters. That should be that could be of 450 meters, 500 meters, 600 meters. So in this problem, what we are going to use is the 600 meters of a total length. So multiplying 600 meters with the RF, we are getting the length of the scale as the 15 centimeters. So first we will draw the 15 centimeters long line. Then we have to it is representing the 600 meters. So I will divide this line into the 6 equal parts, so that the each part will represent the 100 meters. Then I will divide this subdivision into the 10 equal parts, so that the each part will represent the 10 meters. Then further, by use of a diagonal scale, I can divide this uh, division of a subdivision into the 10 equal parts, so that the each part will represent the 1 meter. Okay. So at least 5 centimeter and as long as 7 centimeters. So the height of this line should vary from 5 centimeter to the 7 centimeters. Okay. It is for the better look of the diagonal scale, nothing else. So the next topic is the vernier scale. So these scales are used to read a very small unit with a greater accuracy like the diagonal scales. Means in this scale also the least count is the 1/100th or 0.01. It consists of two parts, a primary scale and a vernier. The primary scale is the nothing but the plane scale, and as it would be difficult to subdivide the minor divisions in an ordinary way, it is done with the help of a vernier. Like in the diagonal scale, it is done by the diagonal scale. In this scale, it is done by the vernier. The graduation on vernier are derived from those on the primary scales, are derived from those on the primary scales. Okay, what this line is mean, you will see when we construct the vernier scale. So basically in this diagram, it is the example of a vernier scale that is called the backward vernier scale, and the another one is the forward vernier scale. So we are going to learn both of these scale. In the first one, we are going to learn the construction of the backward vernier scale. Figure shows a part of a plane scale in which length AO represents the 10 centimeter. So, and in general, suppose it is the X unit. Okay. So, because it is not be always with 10 centimeter, so say that you should have the knowledge of the general solution as well. So, in general, suppose it is the X unit. If we divide AO line into the 10 equal parts, that is in general n parts or n equal parts, so each will be of a 1 centimeter, means each will be of a x by n unit in general. So now it would not be easy to divide each of these parts into 10 equal divisions, means further n divisions, to get the measurements in the millimeters. So the important thing to notice here is the, if you are dividing the primary scale into the 10 equal parts, then you have to divide the vernier scale also into the further 10 equal parts. Okay, and suppose AO, we are dividing the AO division into the 5 equal parts, then the vernier scale also will be divided into the 5 equal parts. So it is very important. That's why it was written here, the graduation on the vernier scale are derived from those on the primary scales. Now we have to take a length BO equals to 10 plus 1, that is 11 in the case of backward vernier. In general, it is x plus x by n, thus representing the 11 centimeters, and divide it into 10 equal parts. In general, n equal parts. Each of these divisions will represent 11 by 10, that is 1.1 centimeters. Okay, so this scale is 11 centimeters now, and we are dividing it into the 10 equal parts. So each part will represent the 1.1 centimeter. So the last digit will be here the 11 centimeters. Or in general, it is the x plus x by n divided by n. So the difference between first part of the AO, that is the 1 centimeter, and one division of the BO, that is the 1.1 centimeter, will be equal to the 0.1 centimeter or 1 mm, and in general it is the x by n square. Okay. So this difference is called least count of the scale. So least count of the scale should may be anything it is not necessary it would be 0.01. It's depend upon the what units are given in the questions. Okay, so minimum in the next line. So minimum this distance can be measured by this scale. The upper scale BO is the vernier, and the combination of plane scale and the vernier is the vernier scale. When the length of the each vernier scale division is larger than the main scale division, it is called as a backward vernier scale. And similarly, we are going to learn the how to construct the forward vernier scale. So the first part is same as the backward vernier scale, that is a part of a plane scale in which length AO representing the 10 centimeters, and we are dividing it into the 10 equal parts, and each part will represent the 1 centimeter. Then we are taking the length BO equal to the 10 minus 1, that is equal to 9 centimeters, thus representing the 9 centimeters, and divide it into the 10 equal parts. Each of these divisions will represent the 9 by 10, that is a 0.9 centimeters. The difference between the one part of AO and one part of the BO will be equal to the again 0.1 centimeter, that is 1 mm, and in general it is again x by n square unit. So in the both scale we are going the same least count. So what is the definition? When the length of each vernier scale division is smaller than the main scale, then it is called as the forward vernier scale. So it is your forward vernier scale. So this length is nothing but the 9 centimeters. So each part will represent the 0.9 centimeters. So here is the first example. So draw a vernier scale of a RF 1 by 25 to read centimeters up to the 4 meters. So the length of 3.39 meters on it. So we can now find the first of all length of the drawing. So length of the scale is the RF into maximum distance. It is coming out to be 16 centimeter. So first we will draw the 16 centimeter long line. Then so the least count should be, here you can see it is the 4 meter, and we have to measure up to the 0.39. Okay, so least count should be, and it is also given in the question also, to read up to the centimeters. Okay, so what we will do is first of all we will divide it into the 4 equal parts as we have done in the plane. We are going to use the same method to divide this line. Then uh, then we will divide this division into the 10 equal parts, and after dividing it into the 10 equal parts, either we can make the forward vernier scale or backward vernier scale. So here we are making the first backward vernier scale, further dividing it into the 10 equal parts. So dividing it into the 10 equal parts, again we will draw a line here, and we will divide into the 10 equal parts. Okay, like this. Then we will join the last point to the 0, and we will draw the Then we will draw the parallel lines. This way you can divide this vernier scale into the 10 equal parts. Okay, so after that we are going to write the units of the scales. Then we have to show the 0.39 meters on it. So how you are going to measure the distance on the vernier scale? It is a very important. Okay, so always look into the last digit of the length that we have to show. Means we have last digit of 3.39 is 9. Then last digit can always be measured in the vernier scale only. Means 0.09. Okay, this 0.09 you are going to, so this 0.09 you are always going to measure in from the vernier scale. So you can see here the 9 is coming out to be here. Means you have to measure the 0.99 from the vernier scale. So in the case of the vernier scale, 0.99 can be measured from the vernier scale, and the remaining 2.4 can be measured from the main scale. Okay, so here you can see the 1, 2 and 4 is coming out to be here. So there is a difference in the plane scale when you dividing it into the 4 parts, then you are dividing this part into 10 equal parts. So there was no need to divide these lines, right? 0 to 1, 1 to 2 and 2 to 3. But here, whenever you are measuring some distance, suppose in this case you are going to measure the 2.4. So 2.4 is in between the 2 and 3. So what you can do is you can divide only this portion 2 to 3. And also suppose if we are using the forward vernier. So in the forward vernier you can measure the vernier, you can measure the 0.09 from the vernier scale. Okay, so the remaining distance will be the 3.3 that you have to measure from the main scale. Okay, so suppose if I have made the forward vernier here. Okay, so I have to measure the 3.3 from the main scale, and if you are making the scale up to the 4 meters, then you cannot measure it from the main scale because the main scale is up to the only 3 meters, right? So in this case there is only one solution, that you have to make the backward vernier only. You cannot make the forward vernier here. So now I have to show the distance of 3.39 in the vernier scale. So here's the next question. In this question, it is given that a map of a size 500 centimeter by 50 centimeter wide represents an area of 6250 square kilometers. Construct a vernier scale to measure kilometer, hectometer, and decameters, and long enough to measure up to the 7 kilometers. Indicate the distance of 5.33 kilometers on it. Okay, so first of all we have to find the RF of the scale. So in this question it is given that the map of a area has given, so we have to convert it into the linear scales. So RF is coming out to be a 2 divided by 10 to the power 5. After calculating the RF, we have to find the length of the scale and the maximum distance that we have to show in the scale is 7 kilometers. So multiplying the area with the 7 kilometers is giving the 14 centimeters. So the length of the scale is the 14 centimeter. Okay. Then we are dividing it into the 7 equal parts so that part will represent the 1 kilometers. Then further we are dividing it into the 10 equal parts so that each part will represent the 1 hectometer, that is the 100 meters. Okay. See, here it is written 10, 30, 50, 70 inside the scale. That is the wrong practice. As I told you, anything you have to write, you should write outside of the diagram. Okay. Then we are going to make the here backward vernier scale. So here it is the unit is a kilometer. This is your hectometer. If you are writing the 0 to 10, suppose you are writing 0 to 1, okay, then you should write here the kilometers. If you are writing the 0 to 10, means it is a hectometer, and suppose you are writing the 0 to 1000, then here the unit will be the in the meters, and you are writing 0 to 100, then the unit will be in decameters. Okay, so then dividing it into the 10 further parts, and each watt will represent the 11 decameters. Okay, then we have to show the distance of 5.33 kilometers on it. So thank you very much, and your first topic scale is covered. Now we will see curves, that is your second topic, in the next video lecture. So thank you for your kind attention.